everything at your end? Great. And have you learned, what are you learning at school in chemistry? Okay. Okay. Um, Before starting a new topic or proceeding into like forward in or inorganic chemistry, can you please revise what we have done in the previous week? Okay. You need to tell me, like, just give me an overview. Okay. So what about the reactivity of halogen? Does it increases down the group or decreases down the group? Decreases down the group. And what is the possible reason? Yes. So there is a shielding effect, increase in shielding effect because the size of an atom is bigger now. There are more shells, and they actually act as a barrier, so nucleus cannot make bond or cannot attract the incoming electron. Okay, and what about the reactivity of alkali? Okay, and why does it increases down the group? On what factor does the reactivity of metals depend? It depends on how easily the atom loses an electron. Okay, so what now? Explain it. Okay, okay, and why is it easy to lose electron down the group in metals? So there is more shielding effect. Great. So it's easy to lose an electron. Okay. Then we have learned about as we discussed the reactivity of halogens, that one halogen can replace the other one. So which is the strongest halogen that can replace all, and which is the weakest halogen? Which group is called as halogens? Group 7. Good. Okay. Which is the strongest halogen? Okay. Good. And the weak one? Good. Iodide or astatine. Iodine or astatine. Okay, correct. Okay, let's move to the next topic then. Our next topic is the reactivity of metals, or how do they react, and what is the series of their reactivity. Okay, when we talk about group 1, group 2, so we believe as we go down the group, the reactivity increases, okay, in group 1 and 2. But what about transition elements? What do you think? Like the middle one in the periodic table. Okay, so when we talk about the groups and periods, the trend is different. So there is, I'll let you know the like uh, a way to learn the reactivity series, or you already know the reactivity series. Okay. Um, okay. Let me give you the one for that. Okay, we'll discuss that when it comes to that point. Okay. Uh, so first of all, let's talk about the reactivity of metals with water. Okay, we discussed group 1 reactivity with water, that they react violently with water as we move down the group. Is it so? Okay. So let's talk about that. What, which element do you think so is going to react more like violently in uh, group 1, most violently in group 1? Francium, good. Okay. And which is the least one? Lithium. Okay. So let's talk about their reactivity and how do they react with water. Okay. When they react with water, what do they form? They form hydroxides, that you need to know. Okay. Okay. There is one easy way to learn the reactivity series. I'm writing over here. Please stop calling me, sorry, a zebra. I truly like her calling me superpower giraffe. Okay. So we say that the one, the first group is most reactive one. So let's start with P. That's P is for potassium. Okay. So it would be the most powerful one, potassium. For S, it's sodium. This is from first group. Then move to the let's move to the second group. Please stop calling me. I missed me. Okay. Calling me is calcium. Me is magnesium. This is group number 1. This is group number 2. This is group number 3. Aluminum. Okay. And Z would be zinc. Oh, where's the pen? Okay, it's zinc. Truly means I. Sorry, I means it's iron. Truly means tin. Like means lead. This means hydrogen. Let me add more. Then hydrogen. Calling is copper. Um, me a powerful giraffe. Okay, the superpower. Sorry, super is the silver, and giraffe is gold. Silver, and then I should move it a bit lower. Just give me a minute. I'll just erase it and rewrite it. Superpower is, oh, didn't set the pen. Silver, and giraffe is gold. Okay, so it would be, please stop calling me a zebra. I truly like her calling me a super powerful giraffe. Okay, okay. The first one, it's according to the group basically. The group wise, group 1, 2, 3, and then again moving to the uh, transition elements. These are then transition elements: the copper, silver, iron, tin, and gold. So group 1 is the ultimate one, which one is the most powerful. And when we move to the inert metals, these are inert metals, silver and copper. Okay, what is meant by inert metals? That they do not usually react easily with the other elements. Okay, okay. So this is your reactivity series. Okay, when we talk about the reactivity series and their reaction with water, so potassium react violently, right? As it's the most reactive one. Okay. What about sodium? Quickly. Okay. What about group 2? Will the reaction of group 2 is similar to group 1? Is it as violent as group 1 or bit slow? Bit slow. So it reacts slowly with water or react less strongly. Same goes with the magnesium, which is in group number 2. Okay. The aluminium one would be same because it's like group number 1, group number 2, and group number 3. Okay, let's move to zinc. Uh, when we talk about zinc, so as the reactivity decreases, so we need to give it extra energy. So we say that these elements they react but with steam. Okay, so they react, this zinc and iron, they react but with steam. Okay, what is the purpose of giving steam? To increase the kinetic energy of elements so that there would be more effective collisions and they react easily. While if we talk about the elements that are below this hydrogen, they are not reactive. Okay, this is how we classify the metals into the groups and the reactivity. Group number 1, group number 2, then the transition elements, then hydrogen, and if they are below the hydrogen, they cannot react with water. Okay? Okay, the next thing. Next thing is we have learned already that how do they react. So let's rewrite the equation. Let's rewrite equation for potassium, calcium, aluminum, or zinc. Okay? Let me choose another pen. Let's go to the reactivity with reaction with water. Okay, earlier we have discussed what do they form when they react with water? Hydroxide. So along with hydrogen gas. So we have calcium plus water. It will give us calcium hydroxide, right? And hydrogen gas. Okay? Okay. Now you need to tell me what would be the product. Zinc plus water. Zinc hydroxide. Okay. And hydrogen. Okay. We discussed earlier as well that when metals react, they form hydroxides or alkalis. But when non-metals react with water, they form acids. Or when or they give acidic solution when dissolved in water. For example, HCl. Sorry, for example, chlorine. It forms HCl. If we talk about the fluorine, it would form hydrofluoric acid. Okay? So we need to know the difference between metals and non-metals. You must know this because further on we have to discuss acid and alkalis. So metals form alkalis and non-metals form acids. Okay, now how do they react with, okay, first of all we have done reaction with water, and because they are alkalis, so they would react with acids. Okay, the reaction of alkali and acid is known as neutralization. This is another term that you must know, that alkalis react with bases and it is known as neutralization. Okay, let's move to metals with acids. Now we are talking about metals only. The first metal is, for example, let's say potassium. Potassium react with hydrochloric acid, sorry, plus hydrochloric acid. So what could be the product? Okay, hydrogen gas would be produced respectively. Okay, it would definitely be there, hydrogen gas, as it produces in the case of water. Okay, so the other one, this part and this part, it will form a compound. So it would sorry, the formation, it would result in the formation of potassium chloride. If it's sodium, sodium plus hydrochloric acid, plus hydrogen. Okay, correct. If it's calcium, correct. Okay, now I'm giving you another acid. If it's sulfuric acid, good. Calcium sulfate and hydrogen gas. Okay, do you know the chemical formula of this hydrochloric acid, the sulfuric acid, potassium chloride, or the calcium sulfate? Do you know how to write it? No? Okay, we need to learn this as well, because now we have to write the equations, and for writing equation we must know how to write a chemical formula. Okay, um, let me finish this topic and then we'll discuss the how to write a chemical formula, because we need to write the equations. Calcium sulfate plus hydrogen. Okay, what about zinc? If zinc reacts with sulfuric acid, zinc sulfate and hydrogen. Okay, and if iron react with chlorine, hydrochloric acid, iron with hydrochloric acid, iron chloride and hydrogen gas. Okay, next one. Uh, we discuss metal displacement. Have we discussed the metal displacement? We have discussed the non-metal displacement. Okay. In the same way is the metal displacement. The stronger one can displace the others, but the weak one cannot. So potassium can replace all. Okay. But zinc can only replace aluminum. Zinc can only replace. one beneath it. Good. Iron, tin, copper, silver, gold. So metals are, so you must know this order first of all. Okay. Um, then the next topic is the rusting of an iron. Why do iron rust? What causes the rusting of an iron? Why do you think so? Okay, what are the external factors that can rust the iron? If you like, I'm talking about I'm not talking about a chemical reaction. I'm asking the like overall phenomena, or what is your observation about the rusting of an iron? Have you ever seen the iron rusting around you? Okay, so what do you think? What factors contribute to the rusting of iron? The air. Good. Okay. What specifically in the air can cause the rusting? The oxygen. Okay. No, it's not oxygen. What else can be? What is present in the air? Okay. What else? What else? Are and water vapors. Okay. So actually, water causes the rusting of an iron. Air also contribute. Air does. Oxygen does. But most of the time, it's water vapors. Okay. Now, to prevent rusting, there like we can do many things. Very first thing is painting. We can paint it, right? So that there won't be the direct contact of iron with the atmosphere. There would be a layer of some, there would be in between layer which prevents the reaction of water with iron. The other method includes the coating with some plastic. You just cover some plastic. Electroplating can be done. Do you have any idea about the electroplating? No. Okay, let me give you an example. For example, okay, many people does this. They have the jewelry of silver, but they additionally added a coating, a layer of gold on it. This is electroplating, and this is done through the electricity process. That's why it is called as electroplating, to plate something on something else. This is the general thing that we discuss. Okay, and what reaction causes the plating of one metal on another one? This is called as redox reaction, the reduction and oxidation reaction. Okay, do you have any idea about the oxidation reduction reaction? No. Okay, thank you. Okay, so we have to learn that in detail as well. Okay, before starting the other like processes, let's learn how to write a chemical formula. Let me write it with blue. um, Writing chemical formula, and then we learn how to write chemical equation. Number one, there's 2 3 steps that you must know. Number one, write the symbol with the correct charge. Okay. Number two, simplify the charge if possible. At the end, cross exchange the charges without plus minus sign. Put bracket if required. Okay, let me give you an example. Let's start with the simplest example. Calcium and chloride. Now you need to tell me the symbol. Let's start with step number one. What is the symbol and charge of calcium and chloride? And the symbol is Ca2 plus. And what about chloride? So chloride is basically chlorine, Cl minus. Okay. Can we simplify the charges 2 and 1? They are already simplified. Good. Okay. Now the third step is cross exchange the charges without plus minus. This 2 would come at the bottom of chlorine and this 1 would come at the bottom of calcium. Okay. So we do not write 1 in chemistry as in algebra, as it's the same case in algebra. In algebra we don't write 1, right? So here we are going not going to write 1. So CaCl₂. Okay, let me give you another one. Potassium oxide. Okay, what is the chemical symbol and the charge on both? Okay, 2 minus. Do you know there are certain charges on each group? Okay, so the final formula would be, it cannot be simplified. This would go at the bottom of potassium, one would go at the bottom of oxygen. So what would be final formula? Good. K2O. Okay. Uh, let's move to the now the difficult one. Let me give you a table. Um, I'm giving you one table that you need to keep that table with you so that you'll be able to revise it better. Okay, this table. Let me see if I can send it to you as well. Okay, I'll send you in the chat as well. Okay, let's see how to write a chemical formula using these, because we have sulfate that we are going to use in acids. Okay, let's write sorry, potassium sulfate. Okay, how to write a chemical formula for this? Okay, good. Okay, another one. mm, Calcium hydroxide. Okay, okay, okay. Now here I have written one point, put bracket if required, right? So here, because we have two elements, O and H, so we need to write this in bracket because 2 is with both. So we will call it CaOH twice. Okay, we would, when we say the formula, we would say it like this: CaOH twice. Done? Okay, I'm giving you one simple assignment. You have take 3-4 minutes and give me the formula for the following. Okay, ammonium, hydroxide. It's in the both are in the table. Calcium sulfate. One is in the table, one is in the periodic table. Zinc, chloride, calcium, oxide, and the fifth one is magnesium nitrate. Take 2-3 minutes and give me the answers.